Both know some of these graphing problems take some time. We discussed that if by chance I happen to be a nice person and you can figure out all the zeros by using your graphing calculator, what should you write on your paper? Saw it on the graph. I heard it from 6, so do you get your point? I don't care if I get Arturo kind of has got things down by now. Maybe he graphs this and he sees the 2 roots on his graphing calculator. For this next test, it's okay if he puts all on graph and then tells me the 2 answers. I'm going to allow it. There are some problems he's going to have to work out, so allowing these 1 or 2 miracle ones is fine. Okay, someone help me factor number 11. I need 2 things that add to 6 and multiply it. B minus 6 and B plus 1. Negative 6 plus 1 is negative 5. Negative 6 times 1 is not positive 6. If I do positive 6 and negative 1, yes, 6, no, 6 times negative 1 is still going to be negative 6. So it's not 6 and 1. It's got to be something else.
2 and 3.
Okay, let's try 2 and 3, but what are the signs?
3.
It has to be a negative 3.
And 2 is also negative.
It has to also be a negative 2. 2, you get the point. Negative 2 times negative 3 is positive 6. Negative 2 minus 3 is negative 5. That one was tricky, I agree. Yeah, we should have thought that through. Well, that's a good question. So Seth asked,
It can be both ways.
and I'm not saying that's not, the only issue with that is negative 1 minus 6 is negative 7. So if that middle term was a negative 7, yes, you'd be completely correct. But because we want the middle to be a negative 5, we have to have the negative 2 and negative 3. That's a good question. Okay, number 12 is my favorite, and it does appear on the test tomorrow. Maybe not in the format you want, but it does appear on the test tomorrow. What is it? It is not perfect squares. It is perfect cubes. 4, you can have your point. Okay, so tell me what I'm supposed to write underneath. Okay, I'll give you a point for SOAP. So same sign, opposite sign, always positive. That's great. I'm needing some help filling some things in, though. It is 2x plus 5 because 2x cubed is 8x to the third. And because 5 cubed is 125, the one on the test tomorrow is a little easier than this one. And I've written too tiny. I'm going to have to write it further down here to spread it out a little. 2x plus 5. And then I know it's a minus and a plus. I need to know the things in between. What? It is 4x squared because 2 squared is 4. X squared is x squared. So 4x squared. What's the very last one, Eduardo? 25, because 5 squared is 25. And what goes in the middle? Because 2x times 5x is 10x. That's perfect, and you're going to have 2 points. So I should help. Again, there is a cubes on the test tomorrow that you will have to factor. However, it's a nice cube that doesn't have a leading coefficient that's also a cube. Well, I guess technically they always have a leading coefficient that's also a cube, because when we don't see an 8, it's an understood 1, and isn't 1 cubed 1 anyway?
I just think that's it.
The middle one is always this times that. 5 times 2x is 10x. So if we had a problem like this, we're supposed to know that 3x to the third is 27x cubed. We're supposed to know that 4 to the third is 64. So if we had this problem, we would have this same sort of format of, I know it's 3x plus 4. Same sign, opposite sign, always positive. We got through my signs. Okay, and then 3x squared. So 3 squared is 9. X squared is x squared. 4 squared is 16. 3x times 4 is 12x. It's always the same pattern with the last one. You square this guy, square this guy. The middle is the 2 of them multiplied together. You can have a point for asking a really good question. Let's do 13 and I'll see what Xavier wants. Let's see. A computer manufacturer determines that the profit for producing X computers per day is this. What is the meaning of the zeros in this situation? So let's graph it and look at it and see what the deal is. Yes, dear. Yes. Yes. No, no one told me that. I'm sorry to hear that, dear. I'm glad you're back.
Besides,
There's-
things, you get that out.
Miss, I don't know when you started being out maybe at all. When did you start being out? As of Monday or before that?
Monday, Tuesday.
Yes, Monday, Tuesday, Wednesday we took notes. We're reviewing today, test is tomorrow, so you're just gonna be behind on the test. But that's fine.
But she needed me to make a test sometime during your period.
That would be great. That would be awesome.
Are there any papers you gave out that I was telling you?
Didn't we get the new notes the week before? Or did we not? Did we get them on Monday? I know we got a new math workshop on Monday. When did we get the new stack of notes? Did we get those on Monday or before that?
You would just go look in the thing, see if there's anything I don't like.
Yeah, our true. Never mind. I have my own notes right here. I don't know what. No, you should already have them because we already did that page before.
Yes, ma'am.
But yes, you would need the math workshop. That's true. Yes, dear.
We got that on Monday.
The calculate. You can't get the last number. Maybe it's from the paper. The 5th. Okay, so today's problem is the realest of them all. You're welcome. We got this function, we've graphed it. It's supposed to be about profit for a computer manufacturer. What kind of function? Why are we mad at it? I know I'm mad at it. And you can have 2 points for that. It's a snake, and we said it was a 4th degree thing. First of all, real life things stink. How dare they not cooperate with these rules we've been drilling over and over again? How dare they? Second thing is a computer manufacturer is trying to make a profit. So, you know, if it's above the x-axis, that means he's making money. If it's below the x-axis, he's not making money. So what does it mean when it's crossing the x-axis? What is the meaning of the zeros? So again, if it's above it, he's making money. Below it, he's losing money. What does it mean when it's exactly on the x-axis? Yeah, he's not making money, he's not losing money. That's when what would we call that in like business? Neutral is pretty good, but if you owned a business and you're not really making money but you're not losing money, what do they call that? There's like a term for that. You break even. Okay, but Mia is correct, and then I'm mad at this graph because it looks like a snake, but it's supposed to be a W. But I'm ignoring this half of the graph anyway. Why would I ignore that half of the graph anyway? And why would we ignore a negative part when we're doing a real example like this? You're not going to have this negative time because the x-axis is probably representing time, and if we read through our problem, it is. It says X computers per day, so we're talking about time. We don't travel backwards in time, so we're literally the part of the graph that Mia's mad at, we would ignore anyway. So, you know, when he starts off, of course, he's breaking even. He loses money for a while. After the 1, 2, 3, between days 3 and 4, he finally starts making money. Okay, so hopefully you wrote something, meaning of zeros, you wrote something about break even. And hopefully you did 2 separate words, because they are 2 separate words. Don't know where my English is going today. Tomorrow's test has it's not a real world one like this, but there is a graph that you're supposed to, that you're going to have to use your words with in order to get all your points. So just be prepared. There is a question that requires words. Okay, we have 2 problems left, and I'm done rambling, and you can work on your study guide. It was yesterday's notes, page 23. We had just discussed this. Come on, focus. Okay, we had just discussed how easy it is. So it's a pain in the rear if you're given a function and you have to determine the zeros, unless those zeros are all real. If the zeros are all real, you can use your calculator and find them, and life's easy. But if we've got some imaginary ones, it's a pain in the rear. But however, what we learned yesterday was the coolest thing yet. If you go backwards, if you're given the zeros and you find the function, it's lickety-split. If you're given the zeros, you know it's the opposite sign. So instead of 5, we did x minus 5. Instead of negative 2, we did x plus 2. Instead of minus 1, we did x plus 1. Now we do have to end up distributing and working this all the way out to get to a polynomial that's in standard form, not in factored form. But hey, we already tested on this middle bit in the first test in chapter 5, so you should be fine. I asked you about number 2. We didn't quite have time to do it. For those who did attempt it, you end up getting x cubed plus 2x squared minus 23x minus 60. Okay, I told you we're going to skip 4 and 6 because 4 and 6 would require, those are the kind of answers, the 3 plus I, that's the kind of answer you would get using that quadratic formula. And we've been skipping all the ones that involve imaginary answers that involve the quadratic formula. We normally just put imaginary answers and move on with our life. So we're skipping 4 and 6. We're only going to work 3 and 5. And I discussed it with Miss Brewster, so I'm going to tell you both the ways I think about it. I wanted to know which way she thought about it, and we think different ways, so I'll show you both ways. Okay, but before I forget, there is one typo on your study guide, which has to do with this kind of problem. That's what's on my brain. On number 13 at the bottom, take off the square root. I don't want a square root today. I just want to. Okay. And since we're on this, and I'm already on the study guide, before I say my new words, there are 2 problems that involve substitution. There are 2 problems that involve, hey, here's a factor, can you figure out the other factors? There are 3 problems where you find all the zeros, but one of them is a miracle one where if you and your calculator were friends, you really wouldn't have to do math. There are 2 problems like what we're talking about today. There's one that's going to be all real numbers, one that's going to involve complex. So that's 2, 4, 6, 7, 8. Yeah, and then the last one is it involves your words. How dare it involve your words? Now, I know we discussed that there was going to be a factoring of cubes problem, and there is. It's hidden inside one of the other problems. I mean, it still makes the test. It's just not a problem on its own. It's within another problem. Like, in order to be successful on problem like 7 or 8, you have to know how to do your cubes. Okay, so the one new thing today, which is not that big of a deal, is how to, if we're given zeros, and there are imaginary zeros, how to go to the polynomial. Okay, well, we should be good with the minus 1. Doesn't that mean I have x plus 1 and x plus 1? They listed it twice, so I did it twice. If I was smart and using my brain, I would probably go ahead and go straight to x plus 1 squared. Because I understand that has a multiplicity of 2. So we've dealt with this 0 and this 0. We have to deal with this last 0. But we talked about this yesterday. Darn the imaginary numbers. They're like girls that go to the bathroom together. They always come in pairs. Always. Always come in pairs. So if we have, a plus 2i as an answer, we also have a minus 2i as an answer. We're going to have them both. So on number 5, what answer do I need to add to my list? Yes, 3 gets the point. We're going to add positive 3i. They always have both. You got to have the plus and the minus. It's a pain in the rear. So anytime you have imaginaries, you got to have the plus or minus. We've had the plus or minus this whole time. So yeah, they try to trick you by only putting the plus, but you need the minus as well, and vice versa. So if you want to, you can list it as, so the opposite sign of that would be minus 2i. The opposite sign of that would be plus 2i. You can list it like this. And then if Paige foils this all the way out, maybe she will, maybe she won't. If she does, she get x squared. Plus 2x and a minus 2x. They would cancel out. So the middle would cancel out. And then last we would have minus 4i squared. But we spent a lot of time on i's. I squared is negative 1. So really I have x squared plus 4. Okay, so I'm going to give Paige some options. Paige can because she's a creature of habit. She did the x plus 1, the x plus 1, opposite sign for the 2i, opposite sign for the negative 2i. She could FOIL this bad boy out, x squared plus 2ix minus 2ix. The middles cancel out. Minus 4i squared. And then she says, oh, I squared is negative 1, so really that's a plus 4. She can do this. And if I FOILed one last time, she'd be done. But if we're being honest, this is not how I think it through. If we're being honest, I go straight to here to begin with, and let me tell you how and why. I don't have to do this mumbo jumbo foiling with complex numbers because I've worked a lot of problems lately, and so have you. And I understand every time I have a plus and then a perfect square number like 16. If you look back on our other problems that have had complex answers, one of the parts looks like this. And when we solve, we end up getting x squared equals negative 16. Take the square root. We end up getting plus or minus 4i. So since I'm smart enough to realize what's going on every single time, it ends up being x squared plus whatever that perfect square would be that deals with that. That's how I knew it was going to be x squared plus 4, because I know 2 squared is 4. So on this next one, I could do x plus 3, x minus 1, x plus 3i, x minus 3i. And again, if Paige FOILs this all the way out, she's going to end up at the same thing as me. But I normally don't bother with that line because I'm smart enough to realize it's always going to end up being x squared plus 3 squared is 9. And again, the reason I realize this is because we've worked so many problems where I end up setting that term equal to 0, that when I solve, I already know I'm going to end up with a negative perfect square. And I know when I take the square root, that's going to lead me to that plus or minus the square root of my perfect square with an I. So if you've noticed this pattern the way I have, you can jump straight to here. But if you think I'm talking mumbo jumbo right now, you need to FOIL and list it out the way we've listed all the others, because Paige could FOIL those two, then FOIL those two, and then put them together, and life would work out the same. It's really up to Paige. Whichever way makes sense to her, that's what she can do. Now, Paige would like it if I finished the darn problems. So I got to this line. I'm still not done. I need to FOIL that one last time. So x times x squared would give me x to the third plus 4x. Oh, I miscounted something wrong. That's x plus 1 squared. So I need to FOIL this bad boy out first. I gotta have some extra room. Lord. It was x plus 1 squared and x squared plus 4. I don't know about y'all, but I'm getting pretty good at FOILing. If you need to list this out, you can. But I already know that's going to be x squared plus 2x plus 1. But if you need to list it out and work it all the way through, you can. And I've got that x squared plus 4. And then just like we were having to do yesterday, I've got to distribute the x squared to everybody. So x squared times x squared is x to the 4th. X squared times 2x is 2x to the 3rd. X squared times x is just x squared. And then I have to, now that I've given the x squared to everybody, I have to go back through and do the same thing with the 4. And I'm not saying it's not time consuming, it is. That's why the test is short. Plus 4x squared plus 8x plus 4. I combine my like terms, which is sadly just these two guys. And I get x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 4. Okay, Lord Jesus, Miss Compton, you sure did say a lot of words really fast. So let's discuss them one last time. We were told, let me write them up here. We were told we had these roots, these zeros. And I'm telling you, if you have the positive version of the imaginary number, you automatically get, for free, the negative version. Now, if you want to do the step before this, where you actually list them out of x plus 1, x plus 1, x minus 2i, and x plus 2i, you're going to have to do an extra foiling that I don't do that will lead you to this. But again, I knew that one in my head, and we talked about why I knew that in my head. I did foil this one out to show you, yeah. And now I've got to put them all together and end up with a really long polynomial at the end. But if you're questioning your sanity, because you're like, oh my goodness, I've had to foil and distribute like 4 times in this problem. Yes, ma'am.
I looked in the box for those notes and there's none in there.
Yeah, they're from last week.
Oh, those are?
Mm-hmm. They're into the packet from last week. Okay, so I worked it all out, and I'm thinking, hey, am I crazy? Because if Paige did this fold out, she did 1, 2, 3 things. And it's easy to make mistakes when you have to do that many different things. The good news is you still got your graphing calculator. You could always graph this bad guy at the end. So it's x to the 4th plus 2x to the 3rd plus 5x squared plus 8x plus 4. So I graph him. And I know I'm right because, again, I see the negative 1 and it has the bounce, so it has that multiplicity of 2. So I see both of these answers. And then you and I both know I wasn't supposed to see those answers anyway. So the fact that it's not crossing a grin on the screen means I did a good job. So if you're questioning your own sanity by the time you've done the third distribution, which I totally understand in life, graph what you have at the end and make sure your graph makes sense with those zeros you were given. Eduardo, you had your hand up. Where did I get 4x squared from? Okay, I did 4 times x squared got 4x squared, 4 times 2x got 8x, 4 times 1 got 4. Are there any other people who want to be brave and ask me about something about my math? Okay, I'm going to stop talking, but you could figure out 5 the same way. Again, when you get to your end polynomial, this is a test. And there is one with a complex number like this on there. So if Paige wants to make sure her thing is correct, graph it, use your graphing skills, and make sure your zeros match what your graph looks like. My 0 is 0. It has a multiplicity of 2. I don't see the other 2. I wasn't supposed to. Yay, I've done a good job. Okay, are there any questions about this?